Assalamualaikum warahmatullahi wabarakatuh. Today we are going to present assignment 1 in the subtopic of operation research. We are from group 3. So today we are going to present about Hungarian method. So first, my name is Muhammad Rafiq bin TUNAN and my metric number is 193769.
My name is ABDUL bin NORUDIN and my metric number is 192562.
Hi, my name is Muhammad Safwan bin ANUARI and my matrix number is 192074.
Hello, my name is AMELIA binti JUHAR and my metric number is 191887.
So we're going to go to in the introduction. Next slide, please. Okay. The subject in operation research is have a subtopic that called assignment model. It includes assign a specific person or worker to specific task or job based on the assumption that the number of people available in equal of number of tasks. The best person for the job is an accurate description of the assignment model. As the example in the picture, this is the general assignment model with n worker and n job is represented in the figure. Next slide, please. The assignment model is actually a special case of the transportation model in which worker represent the source, the job represent the destination. And the Hungarian method was developed and published by Harold Kuhn in 1955. In this assignment model, it have a metric or table connected with it. Generally, the row include the people or object we wish to assign, and the column include the task or job we want them assigned. Consider a problem of assignment of a n source, which is a resource, to the n destination, which is activity. So as to minimum the overall time or cost will such as that each source can connect with one and only one destination. I will pass to Majid to continue.
Okay, thank you, Afiq. So I will explain about the purpose of the loading and the assignment model. So the first of all, an assignment problem is a kind of transportation issue in which the purpose is to allocate a certain amount of resources to an equal number of activity in order to minimize overall cost or maximize the total profit of allocation. So the problem of assignment, of course, because available resource such as workers, machine, and etc. that have different form of efficiency for doing different tasks. Hence, the cost of profit or loss of executing the various operation varies. Therefore, the problem is how should the assignment be arranged in order to maximize the particular objective. So the benefit of doing assignment problem is we can encourage people to study, which is a good thing, and enhance analytical and problem solving abilities, and also to improve patience and endurance amid in the middle of the pressure. So next slide, please. Okay, so the purpose of Hungarian method. So the Hungarian method of assignment offers us with an efficient approach of determining the best answer without having to compare each option directly. So it operates by reducing the supplied cost metric to a metric of the opportunity cost. So the opportunity cost can demonstrate the proportional penalties that is associated with distributing capital to an activity rather than choosing the optimal or least expensive assignment. So if we can minimize the cost metric to the point where there is at least 1 zero in each row and column, so we will be able to make the optimal assignment. So as you can see from the chart in the slide, so this is the general step of Hungarian method. So next slide, please. Next slide. Okay. So I will explain about the example for the I will explain about the problem statement for example one. So as you can see, the Joy has three children, which is John, Karen, and Jerry, that want to earn some money to take care of the personal expenses during a school trip. So Mr. Kai has to choose three courses for his children. There is three jobs, which is moving the lawn, painting the garage door, and washing the family car. So to avoid anticipated sibling competition, so he asked them to submit a secret bid for what they feel is a fair pay for each three course. So the understanding is the children will abide by their father's decision as to who wish get the core. So as you can see from the table 1.1, it summarized the receipt that Mr. Klein received. So based on this information, how should Mr. Klein assign the course to their children, to his children? Okay. So for the solution, for the step one, as we can observe for the table 1.1, so the square metric of this problem is already optimal, which is metric 3 times 3 metric table. Therefore, there is no need to add any dummy row or column. And then for the second step is to make the row opportunity cost metric. So for the second step, as you can see from the original cost metric, we need to identify the minimum number in the row and deduct all the element with the minimum number in order to form the row opportunity cost metric. So this is the solution from the ROCM. And then for the third step is to do the column opportunity cost metric COCM. So we need to find the number in the column and then deduct all the element with a minimum number in order to form the COCM. So from in the table, we can see that we already get 0 for each column. So for the step 4, we need to obtain the total opportunity cost metric, which is TOCM. Once we get the total opportunity cost metric, so we can cover all the 0 by minimum number of the horizontal or vertical line. So as you can see, this assignment problem is a very simple assignment. So we can easily cover all the three line, and then the three line is already equal to the square metric 3 times 3. So if the lines draw is equal to the row or column, which is square metric, so as the final assignment can be made. So in order to make the assignment, we need to search for a single zero, either row wise or column wise. So for this step, I would choose the column wise. So when we find a single zero, so we can assign the cell by enclosing the element of the cell by a square. So as you can see, I already highlighted the single zero in each column. So the cell with the underscore 0 entries can provide the optimal solution. This means we can make the assignment. So Jones get to paint the garage, Karen get to pay to mow the lawn, and Terry get to wash the family car. So the total time required is 27, and the total cost for Mr. Klein to give to his children is $27. That's all for me. So I will pass to Afiq to continue with second example. Thank you.
Thank you, Majid. For the second example, the question is the manager has 4 jobs on hand to be assigned to 3 of his clerical staff. Clerical staff differ in efficiency. The efficiency is a measure of time taken by them to do various jobs. The manager wants to assign the duty to his staff, so the total time taken by staff should be minimum. The metric given below show the time taken by each person to do particular job, help the manager in assigning the job to the personnel. So this is the actual job and the man time taken to do the job in hours. Next slide, please. Okay, the first solution is the given metric is 4 times 3 is unbalanced. So the balance metric 4 by 4 by open the dummy column DC with time coefficient as 0. So we open the dummy column, all the 0 in the column. So the next step is deduct the smallest element in each row from the other element by subtracting smallest element from all other element of the arrow of the row. The metric is known as row opportunity cost metric ROCM. As every row has 0, we consider it as ROCM. So it going to be a ROCM because the all the 0 has of the every row have a 0. Next slide. Okay, next step is deduct the smallest element in each column from other element by subtracting smallest element from all others element of the column. The metric is known as column opportunity cost metric, COCM. By doing COCM, we can write total opportunity cost metric, TOCM. So by doing the subtracting from the smallest element, we can get the TOCM. And the next step is cover all 0 by minimum number of horizontal and vertical. Firstly, cover row column, which is having maximum number of 0, and then the next row or column having the next highest number of zeros, and so until all 0 are covered. So we covered all the 0, and we need to get 4 drawn line equal to the square metric, which is 4 by 4. Okay, next slide. The final step is start the row wise or column wise, which is the optimal solution shown by the shaded 0. So we need find the 0 wise from the column and the row and compare to the actual time taken in hour. So we can get the total time required is 30 hours by sum all the time taken, which is 38 total time required. We can pass to next person.
Okay, thank you, Afiq, for the presentation. So we continue with the example 3, which is example 3 is a company jobs, which is a company has 5 jobs, which is B, W, X, Y, and Z, and 5 machines, A, B, C, D, and E. So the given metric shows the return in RS of assigning a job to machine. So assign the jobs to machine so as to maximize the total returns. Next, please. Okay, so for the solution is, firstly, the objective function is to minimize the return. So the given problem must be converted into minimization problem. So maximization, for maximization, same procedure is adopted. So the maximization problem is converted into minimization problem by multiplying the matrix by -1 or by subtracting all the elements of the matrix from highest elements in the matrix. Once this has been done, the entries in the matrix give the relative cost. Hence, the problems become minimization problem. So once the optimal assignment is obtained, the total value of the original payoff measure can be found by adding the individual original entries for those cells to which assignment has been made. So for the step 1, the highest element in the matrix is 14. So hence subtract all the elements from 14 and write the relative cost, which is called as transform matrix. For the step 2, we deduct the smallest element in each row from other elements of the row. Thus, the metric thus got is known as row opportunity cost metric, ROCM. Next, please. Okay, for the step 3, deduct the smallest elements in each column from other elements of the column. The metric thus got is known as column opportunity cost metric, COCM. And then for the step 4, by doing column operation on ROCM, the total opportunity cost metric, TOCM, is obtained. So total opportunity cost matrix can be got by simplify doing row operation on column opportunity matrix or column operation on row opportunity cost matrix. This method is simple one and save time. Next, please. Okay, for the next steps, we cover all the zeros by minimum number of horizontal and vertical line. So as you can see, firstly we cover the zeros by column scanning and then cover the zeros by row scanning. From this table, the lines thus drawn are equal to the number of rows per column because of square metric. The assignment can be made. If line rows are not equal to the number of row or columns, further steps should be taken. Thus, the number of zeros which are enclosed by the squares is equal to 3 and not equal to the number of rows, which is 5. So only 3 lines are there. So the assignment cannot be made and the following procedure is to be followed. Next, please. Okay, step 6. The cells are covered by the lines are known as covered cells. So the cells which are not covered by lines are known as uncovered cells. So the cells at the intersection of horizontal line and vertical lines are known as cross cell. So the red color element shows the uncovered cell and the green color element shows the cross cell. So the lowest element is in uncovered cell is 1. So hence subtract 1 from the elements of all uncovered cell and add this element to the element cross cell. So do not alter the elements of covered cell and write the metric. So so the next step is cover all the zeros by minimum number of horizontal and vertical line. So as we can see here, the number of zeros which are enclosed by the squares is equal to 4 and equal to the number of rows which is 5. So only 4 lines are there, so we need to proceed to the, then the step 6 is repeated. So the step 8, the cell covered by the lines are known as also as covered cell. The cell which are not covered by lines are known as uncovered cell. So the cell intersection of horizontal and vertical lines are known as cross cell. So as we can see, step 9, recover all the zeros by minimum number of horizontal and vertical line. So thus the number of zeros which are enclosed by the square is equal to 5 and equal to number of rows which is 5. So 5 lines are there, so the assignment can be made. Next. So we start row wise or column wise and go on making assignment until all assignment are over. So the cell with underscore zeros entries provide the optimal solution. So the jobs B is assigned to machine C, jobs W to machine E, jobs X to machine D, job Y to machine B, and job Z to machine A. So the maximized total return RS of this company is equal to 50. So we pass presentation to Amy. Thank you.
Okay, thank you, Safwan. So I will continue with the example 4. So this question is about the transportation problem. So on a given day, district headquarters has the information that one ambulance man is stationed at its 5 locations, which is A, B, C, D, and E. And the district quarter is to be issued for the ambulance van to reach 6 locations, namely P, Q, R, S, T, and U. So the distance in km between present location of ambulance and destination are given in the matrix below. So what we need to do is we need to decide the assignment of van for minimum total distance, and also we need to decide which destination should not expect ambulance van to arrive. So the matrix here is 5 by 6. So we need to balance the matrix to 6 by 6 by opening one dummy row. So after that, we proceed to step 2, which is we need to find the minimum number in the row so that we can form the ROCM. So minimum number here, we have 17, 16, 18, 16, and 15. So after that, we minus all the element in the matrix with the number to form the ROCM. And for step 3, we need to find the COCM. But each matrix has each column have 1 0, so the COCM is obtained, and TOCM is also obtained because the matrix will not change if we have 0 in each column. And then after that, we need to cover all zeros by the minimum number of horizontal and vertical line. Okay, so here we have to cover the dummy row since it have the most zero here, and then we have to cover the S column and also row B and C. Therefore, we have 4 lines. So if we want to optimum the assignment, we need to make a 6 line, which is same with the square matrix, which is 6 by 6. So what we need to do is to find the smallest number in the uncovered cell. So here we have 1, the smallest number. So after that, we will add this number to the intersection of this line. So here we got 1, 9, and 1 here. So all the uncovered cell, we will subtract all these elements with the element 1 here. So this is what we got. And after that, we will repeat the step 4, which is to cover the zeros with minimum line. So if we cover here, we still got 4 lines. So we proceed to find the smallest number. So since the smallest number in the uncovered cell is 2, we need to add plus 2 in here in the intersection of the line, which is 12 plus 2, we got 14, and then here we got 1, and then here we got 10, and then we got 2 here. So all these uncovered element will be minus with the 2. So this is what we got. And then after that, we will cover the zeros with the minimum lines again. So after we covered, we got only 5 lines. So we need to proceed to find the smallest number in the uncovered cell. So after that, we will got this matrix, and then after that, we will cover the zeros with the minimum line up, and then here we got 6 line, which is which means that the assignment is optimal here. So in step 8, we need to search for a single zero, either row wise or column wise. So the shaded zeros cover an optimal assignment. So here we have from destination A to P, B to R, C to T, D to U, E to S, and location Q will not expect to receive any ambulance. And the total distance here is, and the minimum total distance for the ambulance travel is 89 kilometers. So that's all from me. Thank you.